Okay, so I've just published a new section on Moodle here called version control. Now, I'm not finished with automated testing at all yet. We're going to come back to that topic at least once, if not 2 more occasions. But we'll park it for a while and we'll talk about something called version control. And there's a set of slides accompanying this. So version control, also known as source control management, or SCM for short. And essentially what we're going to be talking about is the Git tool, which we've all used at this stage in the labs. Admittedly, I haven't really been talking about it. It's been there in the background. I want to talk a little bit about it now, though, and give you some kind of deeper knowledge, I guess, of what its purpose is and how it works. And how it works is probably what I'm interested in. Now, by no means you have to look up this link, but there is an online book. It's been around for quite a while, but it's still a very good reference point. And I'm just bringing it to your attention, nothing more than that, really. And if you're interested in digging a little bit deeper into understanding how the Git tool works, then this is a very good reference, and I have found it useful in just building up my own kind of knowledge of it. But it's just there for reference purposes. Now, in general, what version control is all about is essentially keeping track of changes that happen to a set of files in a folder. It's as simple as that, really. And by tracking the changes that are happening to files in a folder or subfolders, then what it can also do for us is tell us what changes have happened to a particular file over time. It can compare the current state of a file versus what it was previously and its entire history. And it can do that for every file in a folder or subfolders of that folder. So it's tracking changes and logging changes that are happening to files. And I'm just saying files in general. It doesn't have to be files that contain code. Now, that's where version control systems originated, admittedly, which is why this area is also known as source control management, as in managing and controlling the changes that are happening to source code. But we can use version control systems for any type of text file or any type of file, really, but mainly kind of text files. So even if we had a folder that contained lots of documentation files in it and subfolders that contain just documentation files, we could use Git for managing the changes that are happening to those files over time as well. Git doesn't know anything, does not know anything about source control. So the source control or version control systems are about tracking changes that happen to files so that we can reverse or the state of a file back to an earlier state if we need to. You know, if we make changes to a file and we want to undo them, then we can easily do that with version control tools. And so it's also, it can tell us about who changed the file, when they changed it, and why they changed it, although the why part is really dependent on whether we have documented clearly why we changed a file. But it's certainly from the version control tools point of view, it will take care of telling us when a file was changed and who changed it. And really what the real benefit of these version control tools in the context of software development is that it facilitates collaboration. Because if we've got a large team of people working on a software project, and the notion now of somebody owning a particular code file, that doesn't apply. Anybody has the right to change any source code file within a project. So, but obviously we need to kind of manage those changes, or we need to track those changes, which is what a source control tool will do for us. But if we have that freedom to be able to change any source code file within a project as part of the team, then that means we have a certain safety net, and so collaboration is kind of supported within that team. Now, the next couple of slides, I'm just talking a little bit about the kind of the way these version control tools are architected, or the infrastructure. There are two models really, that the centralized model and the distributed model. I don't want to spend too much time on them, but because that's not really what our focus is. But originally, these source control tools, they were based on kind of a central server, which I'm showing you kind of on the right here. Don't confuse this central server now with GitHub. GitHub is a very different kind of take on this whole area. So just park that for a while. But you had a central server, and it was on that server where we stored centrally the history of our project, let's say. And it stored the copies of each of the files within our project, and it also recorded the history of changes that happened to each file. So it's all resident on the server. Now, we refer to that as the repository. The repository is a bit like a database in a way. It's not a relational database, but it's a database that contains our files within our project, and it also somehow records changes that are happening to those, that have happened to those files over time. So that's resident on a server. And then we as individual programmers, we're working on our local computer. And what we can do is we can ask the server for a copy of a particular file, the most recent copy, more than likely, of a particular file or set of files. We can make edits to those files locally here. And the actual source control software, some of it is running on the server and some of it is running on your local machine. So you've got a client side to it and a server side to it. And on the client side, it will actually keep track of changes that you are making to copies of the files that you have here locally. Okay. So it does that for you locally, tracks what changes you have made to the files that you have made, taken a copy of from the central server. We refer to taking a copy of a file as checking out a file. We ask the central server, I want to check out file A, B, and C. And so we get copies of them here. I make edits to them. The client software running here is tracking those changes. Eventually, I want to push my changes back to the central server. We refer to that as committing our work back to the central server. And the central server will update the local database, update the repository, and it'll also record who made the changes and what changes that were made. We don't care how it records those, it records them some way. So there's this, here's another way of kind of visualizing it. Here's our server on the left, which is where our repository, and it's our central location where the actual, all of the files are being, are stored and their changes are being tracked. Here we have individual team members. Now, when you check out a file or set of files from the repository, we refer to the files here as being your working directory. Okay, this is just the language that we use. So an individual user has a working directory. That's where they can make edits to files. And then when they're happy with their edits, they commit them back to the repository. So this, and so the central server is, we're obviously, if I go back, obviously we're communicating across a network here. So this central server has a URL, and that's how you communicate with it. You do have software running here, client software running here. That's part of the version control package, if you like, and you've got software running on the server. That's part of the version control tool. The alternative model is the distributed model. With the distributed model, each local computer, so you can imagine these are computers now that are owned by each team member, or each team member works on, and there is a full copy of the repository on each team member's local machine. And as a team member makes changes to files and commits those changes to the local repository, the version control software, which is running on each of these machines, they now communicate with one another, and they update each of their own local repositories. So as a particular copy of a repository changes as a result of a team member making edits to files, the software associated with the VC system will take care of communicating those changes to the other nodes on this network, if you like. Okay, so it's a very different model. It's a centralized model. And of course, the advantage of the centralized model over the, this is a distributed model. The advantage of the distributed model is over the centralized model is, if in the centralized model, the server goes down or is not contactable, then the whole system kind of is unavailable. Whereas in this distributed model, if this computer, for some reason, goes down, shuts down, then, the other remaining nodes can still work away independently. Now, originally, this is how Git actually works. It's based on this distributed VCS system. Again, I'll stress, don't confuse this now with GitHub. Mercurial is another one that is based on this distributed model. Now, in terms of what we do and ye are doing in relation to Git, ye are essentially using Git privately. You're not part of a network of Git nodes. You're just working on a repository locally on your machine, and it's completely owned by you. Kind of where GitHub comes into the picture is, you could think of GitHub as nothing more than just a service on the cloud that allows you to make a backup copy of your repository that sits on your local machine. Now, GitHub is a little bit more sophisticated than that, but originally that's all GitHub was meant to be, just a way of making a backup copy. Because obviously, if you're working on your local computer here and your hard disk crashes, okay, and you can't recover it, then you've lost your repository. Whereas with GitHub, you could make a backup of your repository and keep it up to date. And then if your hard disk dies, you replace your hard disk, you can now just recover the backup onto your new hard disk, and you're up and running again. Right, so we have this notion of repository. We still talk about, even when you're working on a local repository here, we still talk about the notion of the working copy and checking out and committing and all of that. That still kind of applies. Check out, maybe not, but committing definitely. So I've got a project, which is really just a folder with files and subfolders on my local machine, and there is a repository connected with that project. And the repository, physically, it appears as a folder within the project, and that's what I'm showing you in this screenshot here. And I'm actually using the little catalog mini project that we've been using in the testing, unit testing labs as the context for this again. So here's a screenshot from my my file system. So I have my, my usual files and folders, but up here there is a subfolder called .git, and that is the repository linked to this project. And when I expand that folder, the reason it's kind of slightly faint is because, its name begins with dot. So in computer science or in file system management, we talk about it being a hidden file, but it's just a folder. It's an ordinary folder. And when I expand it, which I'm showing you on the right here, it has, all various files and folders, which we never go near. We should never go editing any of this stuff. This is the internals of a repository, which you shouldn't tamper with, although we will dig in to see where things are actually stored, okay, to get some sort of understanding on the internal structure of a GitHub, of a Git repository. So if I just flick over to my file system, this is my local copy of, this is just my catalog project, if you like. Now, at the moment, can I see the Git? Should be there, I think. Oh yeah, there it is there. Okay. And if I drill down into it, or if I view it slightly differently, drill down into it, we can see the internals of the repository. So physically, that's all it is. That's all a repository is, just more files and folders. So if you've got a project and you want to use Git with that project, the first thing you've got to do is to create the repository itself. In other words, create that .git folder. And so assuming that we've installed the Git tool itself, then to create an empty repository, we just type this command from the command line, and you must type the command from the base folder of the project. And what that will do is it will create an empty repository. Now, it's empty in the sense that it has no, it doesn't have any copy of your project so far. So if I go back, you'll still see all of this folder structure in an empty repository, but it doesn't have any current, or it doesn't have any copy of your actual files and folders. By the way, in terms of working directory, so this is the Git repository. The working directory is all of the rest of the project folder, if you like, because these are the things that we edit and make changes to. So in version control language, we would say, this is the working directory or the working copy. This is the repository. So Git init will create an empty repository. And the very first thing that we want to do is we want to make a copy of the working directory, make a copy into the repository. And so there's actually two commands that you've got to do to achieve that. We'll see later on why we need two, but once I submitted these two commands, and certainly the second one, the effect of the second one is to cause my Git tool to take all of these files and folders down here and somehow store them somewhere in here. And it'll also record when that happened, and it'll record who I am. When you install the Git tool on your local machine, you can configure it and you can tell it what your name is, your email address. You've done that in the labs, actually. So it's using that name and email address to record who you are when it actually makes a copy of the working directory into the repository. So it now has, at this stage, having done these 3 commands, it now has, if you like, the very first version of your project stored internally in the repository. We tend to, every time we commit changes to the repository, we need to add a statement sort of saying what's the purpose of making this copy. Now, because it's the very first one, we tend to just use a message like this or a statement like this to indicate it's the very first copy. Doesn't really matter what you put for the very first one, but for subsequent ones, it is important. So we call this here the commit message. Okay, so we've got our first version in the repository. Now, just to talk generally for a moment, again, and not specific to Git, what I'm trying to represent here is, let's supposing I've got a project that has just 3 files. Let's keep it simple. And every time I want to update my repository, what the version control tool does is it needs to somehow record what has changed since the previous time you updated the repository. So each of these is an update to the repository. Okay, that's what I'm trying to represent here. Now, in version control tools prior to Git, this is not how Git works now, but in version control tools prior to Git, the way it actually recorded the changes that you've made is by recording just the delta. The delta here is what change has happened to a particular file since the previous update. So if this is my initial commit to the repository, and let's supposing I made some changes to file A and file C, when I then commit those changes, the way older version control tools recorded that changes, they worked out what was the part of the file that had changed, and they just recorded the change rather than a full copy of the file. And so that's what's happening here. It's recording these changes. Later on, I do another update to the repository. In this case, I just make changes to file C and so on and so forth. And so if at any stage I want to find out what was the state of my working copy when I did my 3rd update, then the way the tool works is it kind of works backwards. Well, it starts here and it adds the changes, the deltas itself, and then it kind of reconstructs the file for you, because it doesn't know what the actual state of file 1, 2, and 3 here, or A, B, and C is here. It actually has to kind of compute them using the initial state of the file and the various deltas that have been carried out to it. That's how version control systems used to work in terms of how they stored the changes to your files over time. The Git tool, it does it very differently. It actually makes a full copy of each file that has changed. So you can see now what's happening here is this was my initial commit to the repository. I made some changes to file A and file C on my working directory, and then I committed those changes. And what Git actually does is it stores a completely new copy of file A and C. It somehow maintains a reference back to file B here, because it knows file B hasn't changed. And it keeps on doing that. So every time we do a commit to the repository, it works out, Git works out what file has changed, and it makes it stores a completely new copy of the changed files in the repository. So if, for example, I ask it, can you tell me what the status of file A, B, and C was when I made my 3rd commit? Well, it will have, for file A, it will just simply have a pointer to this file here. For file B, it'll have a pointer back to this one. And for file C, it'll have this itself. So it's very easy for it to reconstruct the status of your project. It's much easier than in the kind of delta model that I showed you on the previous screen. That's just, by the way, that's what's happening behind the scenes. Right. So we have this notion of the working directory. The working directory is where we do all our edits. And what I'm trying to get across on this slide is that the status of the working directory could be one of three things at any particular point in time. Now, let's not get kind of lost in language. If I go back to this project here, our catalog project, let's go back one level. So here's my project, and it has a Git repository, and it has the various files and folders that we're familiar with. And what I've said to you is that these files and folders are essentially these ones here, okay, and this one. They are our working directory. That's the terminology that we use. So if I pull this into VS Code, then, we know if I want to make changes to my source code, I just go in here and open up my file, et cetera, working away. So this is my working directory here. Now, what I'm just saying on the slide is that from a version control perspective, at any point in time, your working directory, its status is one of these three. And again, this is just terminology that we want to get familiar with. The working directory could be in a committed stage. What that means is the repository has the most up-to-date copy of each file stored in the repository. So the working directory and the repository are synchronized. Alternatively, the working directory might be in a modified state. That means you have actually made changes to some of the files in the working directory, but you haven't committed them yet to the repository. So now the repository and the working directory are out of sync because you've got some modifications that you haven't told the repository about, or you haven't committed to the repository. So these are easy enough to understand, these two. There is a third status, which is, and admittedly, initially, it's a bit vague, right? But it is an important status. It's called the staged status. And for now, all I'm saying to you is that the staged status means you have made some changes to files in the working directory. You've told Git that you have made them, but you haven't committed them yet. Now, how do you tell Git that you have made changes, but you haven't committed them yet? Well, if I go back, that's essentially the purpose of the git add command. That's a way of telling Git, look, I've made changes to these files. I'm not committing them yet, though. The -a there is just, you're telling it about all of the files that you've made changes to. Git can actually work out which ones you have made changes to. So you don't have to tell it. You can, but you don't have to tell it which files you've modified. It can actually work it out for you. Now, this is the typical workflow that you, as a developer, would go through when you're using Git. So you begin by creating the repository. I've shown you how to do that. You've created an empty repository. You do your initial commit to the repository. Then you, where are we? Commit the, yeah, that's 3 and 4. Then you go off and you do some editing of files. You do some development work. You stage and commit those modifications. The staging is the git add command. The commit is the git commit command. And you just stay in this 6 to 7 kind of sequence until the project is finished. So that's the flow, and that's what you've been doing in the labs, really. Now, there is this notion of branching associated with Git, which some of you may be aware of. I'm not using branching here at all. Branching is extremely important, but we'll come on to it later on. And so if I just want to simulate this very briefly, although you've all done it, if I go back to, now I've got a second copy of the catalog project here, and it doesn't actually have any Git repository at the moment. Let's just prove that to myself. If I reveal hidden files, well, I am looking at hidden files here. There is a hidden file here, but there's no .git repository. So if I bring this project into VS Code, and from the command line, by the way, you won't see the .git folder here at all, but that's okay for now. But I have proven to you kind of from the file system that there isn't a Git repository. But if I go git init, and if I go back to my file system now, this is the project here, and can we now see? There it is there, sorry. Here's my empty repository. Now, at the moment, the repository doesn't have any copy of my project. And if I do a git add -a, then I'm staging everything, and a git commit -m, and some sort of explanation as to what has changed, but this is my initial one. Okay, and okay, we can make sense of this response now, but that has committed the first copy of my working directory into the repository. If I now go along and make some changes to files, no, you needn't worry about what changes I'm making. I'll just do any kind of change. Save that change. By the way, VS Code has got excellent integration with Git. And you see here, this is the file I changed, and you can see the M here, right? That's actually telling me you have modified this file since you last committed to the repository. If I create a new file, doesn't matter where I create it, but I'll put it into the SRC folder. Let's call it cart.js, and don't worry about what I put in there. That's okay. Here, U here stands for untracked, but Git is actually telling me this. Untracked means you've created a new file, but there's no history of this file in the repository. We refer to that as an untracked file, as in Git is not tracking the changes that are happening to this file. Now, when we next commit, then this file will no longer be untracked. It'll be an ordinary, it'll either be modified or it'll be committed, if you like. So I've made some changes, one modification, one on, and I can now, I've done some editing, and then I want to commit this. So again, I've got to stage them first and then do the commit. Always have an informative commit message, because I'm not doing any, I'm just doing things randomly. I'll just say good commit message. And again, watch what's happened on the left here now, because there's no labels here, if you like, then that's telling me that my working directory is completely in sync with the repository, or vice versa. Or to use the language that I did on the slides there, we would say that my working directory is in a committed stage. Whereas just before I did the git add, git commit, then my working directory was in a modified stage. Status, sorry, was in a modified status, as in I had made changes to files and or added new files, which indeed I had. So that's your typical workflow. Create your repository, commit the initial content of the working directory into the repository, then do some editing, stage and commit those edits, do some more editing, stage and commit those edits, and so on and so forth. Now, I talked a few moments ago about this, the kind of the status of the working directory. There were one of three possibilities: committed, modified, or staged. If we want to talk about a specific file, the status of a file at any particular point in time could be any one of these statuses. It could be an untracked file, which I just explained there a moment ago, actually. An untracked file is a file that exists in your working directory. There is no history of it in the repository. An unmodified file is a file that there is a version of it in the repository, and you have not modified that file since you last committed that file to the repository. So there is a record of it in the repository, and the record of the file in the repository is the most up-to-date version of the file. You haven't modified it on your working directory since whenever you committed that file. And it doesn't have to be the most recent commit. You may have committed it in a much earlier commit, but you just haven't modified it since. A modified, to say that a file is in a modified state, means there is history of that file in the repository, and you have actually made changes to it since you last committed changes from that file. Staged is this kind of odd one. Stage means it's a modified file. You've told Git that you have modified it since you last committed it, but you haven't committed it yet. This is always kind of one that catches people. So there are the different statuses that a particular file might be in from Git's perspective. Okay, this is really this is from a version control perspective, because Git always wants to know what is the status of each file on the working directory. And that's how it works out, how it should maybe change the working directory when you do a git add followed by a git commit. Sorry, how it should change the repository when you do a git add followed by a git commit. This diagram, which I'm not going to talk over, but it essentially shows you how a file can move from one state to a next over time. You can study it yourselves. And so something that we kind of often do as we're working our way through a project is to kind of check every now and again, what is the status of my working directory? Note that this command now is not talking about the status of the repository, it's the status of the working directory. And so when we type that from the command line, we get a response kind of like this, right? Now, if I go back to here and I kind of repeat what I was doing there a while ago, if I make some more changes to some of these files, I'll stick with the same one. Save that. Let's go in here. Forgive me for just randomly cutting and pasting stuff. So. And again, I create a new file as well. So I've modified 2 files and I've created 1 new one. And if I type the git status command from here, then it's kind of telling me what's the status of your working directory. And you know, it kind of makes sense, right? These 2 files are modified. This is an untracked file. Sorry, this is an untracked file. And that's fine. Actually, you know, when you use VS Code, because VS Code has got such good integration with Git, then for me anyway, I don't tend to use this command from the command line. I just watch what's happening over here, because this is telling me the exact same thing. This is essentially being generated from git status. But you should be familiar with the commands anyway, because you may not have access to VS Code, or you may want to check a working directory without being able to pull it into VS Code. So git status is the same as what we're kind of seeing over here, these little labels here on the right. And that's how you check the status of the working directory. And all I'm doing here in these slides is just walking through a scenario. So if this was the status, well, actually, let's do it back here. Okay. So it's telling me so that these files are modified and this one is untracked. If I now do a git, and also keep an eye on what's happening to the labels over here. If I do a git add -a, the -a means take all of the changes from my working directory and stage them. Okay, and how does it know which modifications should be staged? Well, it can actually compute it itself, because I ask it here to tell me what's the status of my working directory, and it worked it out for me. So when I tell it to stage all of the changes in my working directory, it will be able to work out, you know, what does it need to stage. I don't have to tell it to stage specific files. It can actually compute that itself. So I've hit return. Then you can see here, like it's made slight changes to the labeling. A here means that it's going to be adding. If I do a commit now, it's going to be adding this file to the repository because it's the first time that it's seen it. It's going to be modifying the record of this file, and it's going to be modifying its record of this file. By modifying its record, I mean, you know, it's going to recall the fact that the file has changed, and it's going to make a complete copy of this file and store a completely new copy of them in the repository, as well as taking a complete copy of this one, obviously. But if I do the git status command again, you know, you can see that there's been slight changes here in terms of how VS Code records the status of my working directory now. Similarly here, if you compare and contrast this response from git status versus the earlier response, they are different. And if you read the actual, like it's telling me here, these are changes that are about to be committed, which is kind of different from what it's telling you up here. Here it's just telling you, look, you've modified these files and you've got another file that's untracked so far. And the next thing I can do then is do a git commit. Now, please don't do stuff like this, have meaningless messages, but I call it git commit message 2, let's say. Now, when I hit return, all of these are going to disappear. And because there will be no labels here now, that means my working directory and my repository are in sync, or to use the language, my working directory is fully committed to the repository. Error, what did I get wrong? Oh, sorry. So yeah, there's nothing appearing here. And if I do a git status again, it's telling me that, what is it telling me? Yeah, nothing. This is the important part, I suppose. There's nothing to commit because you haven't made any modifications. Right, that's that. Caveats to the above. So when we did the git add command there, I used the parameter -a, which means I want to stage everything that's has changed in my working directory. I want to stage all of them. But sometimes you may actually only want to stage some of them. And so you can specify which particular files you want to stage, even though I might have mentioned earlier on that you tend to stage everything. You don't. So if you can imagine, I am working on my project and I'm making changes to various files. I may be carrying out 2 sort of tasks simultaneously. So I'm making changes to various files and I've completed one of the tasks, but the other task I haven't completed yet. So the edits that I would have made to files related to the second task, I probably don't want to stage and commit those yet because they're incomplete. But I do want to stage and commit the files that I've edited relating to the first task. So that would be an example where my working directory has lots of modifications to it, but I don't want to commit all of them. And so I can specify which particular files I want to stage, and then I commit them. Notice in my commit message, the git commit command, you don't specify files. In fact, you cannot specify what files you are committing. You have to do that with the git add command. So anyway, you can stage specific files. You don't always have to use the git add -a option. And then when you do your git commit, immediately afterwards, obviously. Now, if that is the case, like where you've modified a number of files, but you've only staged and committed some of them, then clearly your working directory still has some modified or untracked files. So when you do a git status after this commit here, you're still going to be told that there are some that your working directory and your repository are not in sync at this stage. And that's fine. That's kind of a normal situation. Now, the commit message is extremely important. The commit message should communicate why you made the changes that you have made. Note I'm emphasizing why. Don't include, or try not to include in a commit message what files or what changes you have made. It's easy for somebody to find out what files were changed and where were they changed. There are Git commands that will do that for us. But what is important is to express why you made the changes. So that might be, I fixed a particular bug for a particular feature, and you'd be specific about what the bug was and what the feature was. Or I have developed a particular feature, and you'd be specific about what feature you developed. Or I refactored a particular aspect of the code base. But try and express, so when you're trying to come up with a commit message, ask yourself, why did I make these changes? And then the answer to that question is what goes into the commit message as succinctly as you can. And what the commit message is really for is it's a way of communicating to other members of the team as to why the person made this commit. It's not so much for you, but it's for other members of the team. So it's a form of communication really with the team members. So what am I saying? Managers should, oh yeah, okay. So like some software houses actually have predetermined formats for these commit messages or a particular structure that you have to follow, but we won't necessarily go into that now, but it can be the case. And if you cannot express it in a short kind of sentence like this, then you can actually put the commit message into a text file of some sort if you want to elaborate more on the why, the answer to the question why. You can put it into a text file, and you can just refer to the text file here rather than actually typing the message here. So as I said, it facilitates communication between team members, which is all part of this kind of collaboration idea that I mentioned at the outset. The next point is you shouldn't commit everything to the repository. Any files that are generated by other tools that you're using, for example, if you're developing a Java project, and the compiler generates .class files, you should never commit .class files to the repository. In the case of a JavaScript project, you should never commit the node modules folder to the repository, because that just contains third-party libraries, and we can get those by some other means. We don't have to store them in the repository. Or log files would be another example. So anything that's generated or automatically created by some other tool behind the scenes, but are part of your working directory, then you should not commit those. And how do you tell Git to ignore certain files? Well, there is a special file called the .gitignore file, which you use for that purpose. And you've seen it. You may have noticed it in the catalog project. Here it is here. And the next day we'll talk about how you put entries into this file. It's extremely important, and you've got to get it right. You've got to get the gitignore file correct from the outset before you do the first commit. Because if you forget about it, then it's kind of too late. You've already now told Git about certain files, and it has a record of them in the repository, and it's too late to undo that after your first commit. Okay, I'm going to stop there, and we pick up the story the next day. So I'll talk to you next Tuesday, I guess.
See you next Tuesday.
Bye-bye.